welcome to Pepcoding. So in this video we are going to discuss a very interesting question, which is left view of a binary tree. So you will be given a binary tree and we have to print the left view of it. So let us discuss the question first. So suppose we are given a binary tree, and what we have to do for now, just assume there is a person standing over here, okay, and this person is keeping an eye on this binary tree, okay. So when the person will try to see the left view of a binary tree, then which nodes he can see? See, like this. See, 3 is hiding behind 12. Person can, starting from the root, the person can see 7, the person can see 3, but he can't see 12 because 12 is hiding behind 3. Okay, the person can see, if the person turn his eyes to the down, then he can see 1. Yes, he can't see 6, 9 and 13 because these all are hiding behind the 1. Okay, so the person can see 4. Yes, he can see 4. Now assume if there are some nodes like this, there is 14, then 19. So just think of whether the person will be able to see the 19. Yes, the person can see 19, but person can't see 14 because in this level the 14 is hiding behind the 4. So now let us discuss some other points, how we will figure out this problem. See, the person can see 7, 3, 1 and 4. If we'll divide this tree in levels, then this will be level 0, this will be level 1, this will be level 2 and this will be level 3. If you will notice a thing that if we have to traverse level order wise, means like this is level 0, then this is level 1. If we'll traverse in this binary tree level order wise, then what will be the answer? We will travel at 0th level first, then at 1th level, which will be 3 and 12, then at 2th level, which will be 1, 6, 9 and 13, and to the last level 4. So we'll take help from this level order wise traversal. Means we are doing level wise processing. First 0th level is processed, then first 1th level is processed, then 2th level is processed, then 3rd level is processed. So here we are using level wise BFS. So see, when we are processing 0th level, then we need to first store this 7, and then we will call the children of 7, that will be 3, 12, and then what we'll call children of 3, and then we'll call children of 12, and then we'll call children of 1, which are nothing, then we'll call children of 6, that is 4 only, then we'll call children of 9, which is nothing, then we'll call children of 13, which is nothing. So this is how we'll implement to see the left view of a binary tree. So here what we'll be doing, we'll be using queue. Actually we'll be making queue using linked list. Okay, we'll be making queue out of it. Okay, how we will implement this thing? See, we'll basically use two functions of queue, which is add last and remove first. See, if we'll recall the question, which is level order wise traversal, then what we have learned over there, there is a separate question in the level 1, which is of level order wise traversal in binary tree. If you haven't watched that video, then first go through that video, then you will understand this thing very well, that what basically we used to do in level order wise traversal, okay, in a binary tree. So what we used to do there, firstly we will add 7 to the queue. Then what we'll do, we will see after in 0th level there is only one element, that is 7. So we will add all the elements of 0th level, so that is only 7. Now what we'll do, we'll add its children, we'll add its children, and we will remove this 7. So basically we are adding from last and we are removing from first, okay. So we are adding at last and we are removing from first, okay. So after inserting the childrens of 7, we have removed the 7, and then what we'll do, this here level 0 is completed. So now we will make a call to children of 3. So children of 3 are 1 and 6. So children are added. Now what we'll do, we'll remove 3. And now next what we'll do, we will make a call to children of 12, which are 9 and 13, okay, and then we will remove 12. Now what, now we will call children of 1, but there is no children of 1, so we will add nothing and we will remove first. So what we are basically doing, we are adding we are removing the nodes after adding its children. So first add the children, then remove the node, okay. This is what we are doing. So we have added we have removed 1. Now we will check for children of 6. Children of 6 is 4, we'll add it and we'll remove 6. Children of 9 is nothing, so we'll add nothing and we'll remove 9. So we'll check for children of 13. Children of 13 is nothing, so we'll remove 13 and we will add so we'll remove 13, okay, because it has no children. Now what is left, 4. Children of 4 is nothing, so we will remove 4. So if you will notice a thing, that whenever we are going into another level, see, whenever we are going into another level, the very first element of each level is the element belonging to left view of our binary tree. So what will be our left view of binary tree will contain in this particular tree? 7, 3, 1 and 4. So every element coming first at each level will belong to our left view. So 7 is the only element. 7 is the very first element in 0th level, 3 is the very first element in 1th level, and 1 is the very first element in 2th level, 4 is the very first element in 3th level, okay. So this is how we will implement our logic. So let us move to our code section, then we'll code for whatever we have done over here. So here we'll code for our left view function, okay. So our first step to create a queue out of linked list, queue of nodes, p node, and what next, we'll push this root value, in our queue. Let me erase all these things. Side by side, we will also do the dry run. So we have created our queue. So queue is created, and here we have inserted our root value, and the size of queue is 1. So let us insert. So we'll add at last. So queue dot push root value. Okay, root value. Now what we'll do, we'll iterate through queue dot size. We'll iterate through queue dot size till size is greater than 0. And next what we'll do, see, in the first step we have to just print the root, means the very first node at level 0, level 0, 1, 2, 3. So this is very first node at level 0. So we will print this thing. See, we have to return the vector. So we will first create our vector answer vector. So this is our answer vector, and we'll push the value in our answer. Push back q dot print value. Okay. So what will be our next step? Our next step will be, we'll create a while loop and we'll decrease the size one by one. How? This thing we have discussed when we were giving when I was giving the explanation of the question, and rest you will understand when we'll do the dry run. So size minus minus to be greater than 0. Okay. So now what we'll do, we'll remove the element and add its children. Then again remove the element and add its children. So our next step is removing the node. So we will remove from front. Okay. Now we will check whether the element at this whether its right children, whether the node removed has its right children and left children. If it is having its left children, then we will push that its left children in our queue, and if it is having its right children also, then we will push its right children in our queue. So let us check its for its left children. If it is not null, then push it in the left. Okay. Push it in the queue. Push this removed the left, push the left children of this removed node in queue. Okay, this is what this statement is saying, and same thing we will do for its right children. This will be m dot right. Okay, now what we'll do, whatever we have stored in our answer, this answer will return this. Now for once we'll do the dry run of it, and then you will understand the things well. Okay. So I hope it is visible. So our very first step is we have pushed the root value in the queue and the size of queue is 1. We'll check this while condition. This will be true and then we'll push this value in our, so we'll also maintain our answer. So we'll push this value in our answer and size is 1 and now we will iterate in the size. So we'll remove this from front. This is front of queue. We'll remove from here and we'll check whether this removed, the left children of this removed value is not equals to null. So it is not equals to null. So we'll push this left children in queue. So we will push its left children in queue. Okay, and we'll check also for the right children. It is also not null. So we'll push its right children in the queue and then size will become 0 and 0 greater than 0 condition false. So we'll come out of this while loop and we'll move up. So here q dot size is 2. So here q dot size is 2. Now what we'll do? We'll come inside and we'll push what? We'll push front value in q. What is front value right now? This is the front value. So we'll push this front value in q and we'll come inside this while loop and we'll remove a front value from the queue. Front value is 3, so we'll remove this and we'll check the children of 3. So left children of 3 is 1, so we'll push in the queue. Left children of 3 is 6, we'll push it in the queue. Sorry, we have to, this is answer. So we are not supposed to push over here, we are supposed to push in a queue. So left children of 3 is 1, right children of 3 is 6. Okay, so what next we have to do? So size was 2, now it became 1. So now when size is 1, again we'll check the condition for 12. We'll remove 12. 1 is greater than 0, that is why we'll remove 10 from front. Right now this is front and we'll check the children of 12. Children of 12 is 9, not null. Children of 12 is right, children of 12 is also not null, so we will add in the queue. Okay, now size will become 0. We'll come to while loop. 0 is greater than 0, condition false, so we will move out of this while loop and we'll check the while condition. Q dot size, which is equals to 4, is greater than 0. Yes, so we will push this one. We'll push this one in our answer and we'll iterate through size, which will be 3, 2, 1, 0, and we'll add its children. So we'll add 4 and size has become 0. So when size has become 0, then again we'll come out of this while loop. We'll enter into this while loop. Q dot size is 1. So we'll come inside it and we'll push back the front value of Q, which is 4 in our answer. And size 1 is greater than 0. So we will remove from front and we'll check its children. We'll check the children of 4. Children of 4 are nothing. So we'll add nothing. And then size has become 0. We'll check size is greater than 0. No, condition false. We'll come inside this while loop and here we'll check q dot size is greater than 0. No, q dot size is not greater than 0. So we will come out of it and we'll return our answer. Okay. So now we will run our code. So there is some mistake. Answered. Okay, so it will be answer dot pushback. Okay. So there is some more error. Val B was not declared in line number 46. Okay, so val variable is not declared. So this is val. Okay, so because we are pointing to the value at q dot front value. Now let us run the code. So there's some more error. So okay, so this will be q dot front. Now successfully accepted. Now let us submit it. Okay, so that's working fine. So that's the end of our video. I hope you have understood the problem and the solution. So we'll be meeting in another video with another question. So thank you for watching.